We have our final talk of this session with Clair Blacketer, validating a scalable approach to data fitness for purpose, database diagnostics applied to Legend T2DM.
Well, thank you so much. Thank you for staying with us until the last lightning talk. I appreciate it. And I just want to give a big thank you to the Odyssey Scientific Review Committee for allowing me to share this work with you, and to my co-authors for their unwavering support, even though I email them very, very often. So as we heard earlier this morning, federated data networks are integral to increasing the trust in the evidence that we generate. But as we've been increasingly relying on these networks, we've been seeing this challenge arise where it is difficult sometimes to identify the databases in a network that are best fit to answer potential study questions, especially now when we very often do not have access to patient-level data. So in answer to this challenge, a couple of years ago, we developed database diagnostics. And in a nutshell, what it does is every database in a federated data network generates a database profile, or just a simple set of summary statistics that they then send to the Odyssey Coordinating Center, or the coordinating center of their respective network. And then that coordinating center, each time a study owner or someone who wants to ask a question of the network, they can utilize those summary statistics to help figure out, given the building blocks of the study or the question you're interested in, which databases are potentially best fit to answer that question. And as we talked about earlier, this is what we've been doing in the evidence network, and so far it has worked well, but we have not yet validated this approach. And that is what we attempted to do in this study. So we've heard a lot about Legend diabetes today, so I'm not going to go through all of it with you right here, but just as a reminder, it is a study that we conducted over the course of the last few years, and we had a really large plenary session on it last year's Odyssey Symposium. But it looked at 4 second-line anti-hyperglycemic drugs, looking at the safety and effectiveness against 32 different outcomes. And I'm not going to go through all of the different ways that the Legend diabetes study made sure there was, oh no, I don't know what's happening. Okay. Okay, well, we're just going to leave it there. Maybe, I'm not touching anything. I'm touching the buttons that I'm supposed to touch. All right, well, anyway, there are lots of ways that we were trying to ensure power in Legend diabetes, and one of the ways we did it was by making sure that there were at least 1,000 patients per arm, or there are at least 1,000 patients exposed to each of the drugs in each database. And so with that, we actually developed 2 different objectives. Oh, next slide, please. Thank you for helping me out. Oh, magical fairies in the sky. Next slide, please. And you can just click my build, please. Well, the first objective, we looked at the targets and comparators. So like I said, in the Legend diabetes study, we were looking to make sure that the databases had at least 1,000 persons exposed. And really this was to support the large-scale propensity score modeling. And we wanted to know, could database diagnostics accurately identify databases upfront that had at least 1,000 persons exposed in each arm without access to that patient-level data? And then objective 2, next slide, please, was we started looking at the outcomes, just to say, can data diagnostics accurately identify databases with representation of those 32 outcomes of interest? Next slide. So what we then did was we said, okay, here was what the Legend study looked like. Let's translate that into database diagnostics speak. So that's kind of what you see up here on the screen. So we took those 6 T and C comparisons against the 32 different outcomes and translated those into 192 different data diagnostic settings objects. We then executed those 192 objects against 12 different databases that had both database profiles available for them, or those summary statistics, and then also had contributed results to the Legend Diabetes study. We then looked and said, did database diagnostics accurately predict those databases that could support the Legend study questions? Next slide, please. So first off, let's start with the target and comparator results. So to orient you to this graph, the y-axis is the percent of databases that meet that 1,000 person threshold. The x-axis is each of our different drug classes. And then the pink bar there is what database diagnostics predicted. And the purple is our Legend kind of reference standard. I will say Martijn and I went back and forth on these colors because they really don't mean anything. I just like them. And so you can see here the pink in data diagnostics really did overestimate a little bit those databases that could meet that 1,000 person threshold for each of our drug classes. And when we looked into it, it actually had to do with our phenotyping, as Judy was talking about earlier. So in Legend here, what we looked for was not only was a person exposed to the drug, but they couldn't have any prior exposures to the other drugs that we were interested in. So then what that really means is, data diagnostics is only taking the marginal summary statistics. We have no information on combinations of variables, and that's for multiple different reasons, but the biggest of which is we do not want to open ourselves up to inappropriate use of these data or these summary statistics. So really what we found was when the phenotypes are a little bit complicated, data diagnostics struggled to identify those that could support that 1,000 person threshold. Next slide, please. But if we take a look at the confusion matrix here, so what I'm looking at is data diagnostics prediction against the Legend results. Here what you see those 9 false positives I was referring to before for the targets and comparators. But importantly, we had 0 false negatives. And that was what I was really excited about, is that at no point did our method fail a database that was ultimately able to go on and generate evidence to support this study. And that's really important, I think, when we're talking about early fit-for-purpose assessments. Next slide. And if we move on to our outcome phenotypes, the results were even more promising here. So again, you see our false negatives of 0, leading to that high sensitivity. But in this case, we only had 4 false positives, which led to a specificity of 93.75%. And what was really exciting as we looked at the results is not only did database diagnostics identify those databases that could not support individual outcomes, it also told us why they couldn't support it. And that was really interesting as I compared the results from the Legend Diabetes study back to what data diagnostics was telling us, and getting that insight into why was really helping me identify potential data quality issues or potential design issues with our phenotypes. Next slide. So just for a couple key takeaways, what we found in this validation work is that database diagnostics showed perfect sensitivity and strong specificity when identifying databases with potential to generate evidence for each outcome, importantly identifying why a database fails a given study design. And in relation to the targets and comparators, it reliably identified databases with any exposure, but was less accurate at meeting that 1,000 person threshold when those definitions are complex. Next slide. So come meet me at the poster for more details if you'd like to chat. I just want to say I don't have a cool radio show like Judy does, but I still hope you'll come chat with me and we can maybe make this method even better in future. Thank you.